March 17th, 1943. North Atlantic, approximately 580 nautical miles west of Ireland. Kapitänleutnant Hans-Joachim Hesse stood in the control room of U-192, reviewing damage reports from the previous night's depth charge attack. The Type IXC submarine had survived, barely, after 16 hours of pursuit by a British corvette. Standard procedure. The destroyer would pass overhead, drop a pattern of depth charges set for various depths, lose sonar contact in the turbulence, then spend 30 minutes reacquiring the target while U-192 crept away on silent running. But something had changed in the last engagement. The hydrophone operator, Oberbootsmann Friedrich Kemper, had detected unusual sounds during the final attack run, not the familiar whoosh of depth charges tumbling through the water, their detonations predictable and survivable if you maintained depth discipline and proper evasion. These had been different. Multiple small splashes, almost simultaneous, followed by silence. Then, without warning, the ocean had erupted around them, with 24 individual explosions occurring within a 2-second window, each detonation occurring precisely at U-192's depth. The submarine had survived because Hesse had ordered emergency deep dive 30 seconds before the attack, pure instinct rather than tactical calculation. But the damage was severe. Hull plates cracked, battery compartment flooding, compressed air system compromised. They would not survive another encounter with whatever weapon had produced that devastating barrage. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What Kapitänleutnant Hesse and his crew could not know was that they had just survived the first combat encounter with a weapon system that would fundamentally transform anti-submarine warfare. The Hedgehog anti-submarine mortar, officially designated Projector, anti-submarine, Mark 10, fired 24 65-pound projectiles in an elliptical pattern 100 yards ahead of the attacking vessel. Each projectile carried 35 pounds of Torpex high explosive, detonating only on direct contact with a submarine's hull. Within 8 months, this single weapon system would increase U-boat kill rates from approximately 5% to nearly 25% per attack, forcing Admiral Karl Dönitz to completely revise German submarine tactics and contributing to the loss of over 120 U-boats before war's end. The psychological impact would be even more profound than the statistical casualties, as U-boat crews realized they were facing a weapon against which their traditional evasion tactics provided no protection whatsoever. The Battle of the Atlantic had established certain tactical assumptions that both sides understood and operated within. British and American anti-submarine doctrine relied primarily on depth charges, cylindrical containers filled with 300 to 600 pounds of explosives, detonated by hydrostatic pistols set to explode at predetermined depths. A typical corvette or destroyer carried between 40 and 100 depth charges, releasing them in patterns designed to bracket a submarine's probable position. The tactical choreography had become grimly familiar to both attackers and defenders by early 1943. Surface ships would detect a submarine using ASDIC, the British sonar system that transmitted sound pulses and detected echoes from submerged objects. The attacking vessel would close to the submarine's position at maximum speed while maintaining sonar contact. At approximately 200 yards range, sonar contact would be lost as the submarine passed beneath the ship's hull, disappearing into the sonar's dead zone directly below the transducer. At this point, the attacking ship would release its depth charge pattern, typically 4 to 8 charges dropped in quick succession, each preset to detonate at different depths to cover the probable range where the submarine might be operating. The charges would sink at roughly 10 feet per second. A charge set for 150 feet depth would detonate approximately 15 seconds after entering the water. During those 15 seconds, the submarine could maneuver at speeds up to 8 knots submerged, traveling approximately 200 feet from its position when sonar contact was lost. The explosions from conventional depth charges served 2 purposes beyond direct hull damage. The pressure waves could crack hull plates, rupture piping, damage machinery, and incapacitate crew members through concussive force, even without direct hits. But equally important from the attacker's perspective, the massive underwater detonations created turbulence and temperature gradients that made sonar completely useless for several minutes, sometimes longer in shallow water where multiple reflections persisted. This sonar blindness represented the fundamental weakness in depth charge attacks. After dropping its pattern, the attacking ship was effectively blind, unable to confirm whether the submarine had been hit, forced to surface, or simply evaded the attack. The ship would circle the area, waiting for sonar conditions to clear, hoping to reacquire contact. Meanwhile, the submarine would exploit this window to escape, using the turbulence and noise to mask its movements. German U-boat commanders had developed sophisticated evasion techniques based on this tactical pattern. Oberbootsmann training schools at Pillau and Danzig taught specific maneuvers. When sonar contact was detected, the boat would initially maintain course and speed, not alerting the attacker that detection was known. As the surface ship closed to attack range, the U-boat commander would order maximum speed on electric motors, typically 7 to 8 knots for Type IXC boats, combined with sharp course changes and controlled depth alterations. The critical moment came when the submarine passed beneath the attacking ship and sonar contact was lost. At that instant, the commander would order emergency maneuvers, often 90-degree course changes combined with rapid depth changes, attempting to be as far as possible from the projected impact point when charges detonated 15 to 20 seconds later. If the boat could travel 300 feet from its last known position during that window, and the depth charge pattern only covered a 200-foot radius, survival was probable. This tactical dance had been practiced thousands of times across the Atlantic. U-boat crews understood the rhythm: detect sonar, evade, wait for depth charges, survive the concussion, exploit the sonar blindness to escape. Repeat. Casualties occurred when boats were caught by surprise, when evasion maneuvers failed, when accumulated damage from previous attacks degraded mobility, or when multiple attacking ships coordinated their patterns to cover larger areas. The statistics from early 1943 reflected this tactical stalemate. Of approximately 1,000 depth charge attacks documented by Allied forces during the first quarter of 1943, fewer than 50 resulted in confirmed U-boat kills, a success rate below 5%. Most attacks caused some damage, forcing boats to return to port for repairs, but outright destruction remained statistically rare. British anti-submarine warfare analysts at Western Approaches Command in Liverpool studied these engagement reports with growing frustration. Captain Frederick John Walker, arguably the most successful anti-submarine commander of the war, had developed sophisticated tactics using multiple ships in coordinated attack patterns. His famous creeping attack involved one ship maintaining sonar contact while directing a second ship to drop patterns over the submarine's position, reducing the sonar blind period. Even with these innovations, kill rates remained disappointingly low. The fundamental problem was temporal and spatial. The window between losing sonar contact and delivering weapons to the target was too large. Submarines could escape during that window using relatively simple evasion maneuvers. What anti-submarine forces needed was a weapon that could be fired while maintaining sonar contact, delivering ordnance ahead of the attacking ship rather than astern, eliminating the critical blind period that allowed submarines to escape. The Hedgehog anti-submarine mortar addressed this tactical requirement through revolutionary design principles. Development had begun in 1940 under the supervision of the Directorate of Miscellaneous Weapons Development, a British Admiralty department responsible for unconventional weapon systems. The project was led by Lieutenant Commander Charles Goodave of the Royal Naval Volunteer Reserve, working with designers from the Fairlie Marine Company. The system consisted of a steel frame mounting 24 spigot mortars, arranged in 4 rows of 6 launchers, angled to fire forward at approximately 45 degrees. Each launcher was essentially a fixed steel rod, the spigot, onto which a projectile was loaded. The projectile itself, officially designated Mark 9 or Mark 10 depending on variant, was a streamlined finned bomb, 65 pounds in total weight. The explosive charge consisted of 35 pounds of Torpex, a mixture of RDX, TNT, and aluminum powder that was approximately 50% more powerful than TNT alone. This relatively modest explosive charge, less than 1/10 the size of a standard depth charge, was sufficient because Hedgehog projectiles only detonated on direct contact with a target. Each projectile incorporated a contact fuse in its nose, designed to explode instantly upon striking a steel hull, but to remain inert if it struck the ocean floor or drifted harmlessly past the target. The firing mechanism used cordite cartridges to propel each projectile off its spigot. The launch sequence was staggered over approximately 6 seconds, with projectiles leaving the launchers in rapid succession. The mounting was designed so that the different angles and slight timing variations created an elliptical impact pattern, approximately 130 feet long by 40 feet wide, centered approximately 230 yards ahead of the firing ship. This forward-firing capability represented the weapon's revolutionary tactical advantage. A ship could approach a submarine contact, maintain continuous ASDIC tracking throughout the attack run, fire the Hedgehog salvo, while still 230 yards from the submarine's position, and never lose sonar contact. The projectiles would arc through the air for approximately 5 seconds, strike the water, and sink at approximately 23 feet per second, maintaining their elliptical pattern as they descended. If the submarine maintained its course and depth, the projectiles would arrive at the target depth with the submarine still within the impact pattern. If the submarine attempted evasion, sonar could track its movements in real time, allowing the attacking ship to adjust course and fire additional salvos. The critical blind period that had allowed thousands of U-boats to escape depth charge attacks had been eliminated. The contact fuse design provided an additional tactical advantage that Allied commanders initially underappreciated. Conventional depth charges exploded whether they hit anything or not, creating massive underwater turbulence that made sonar useless for several minutes. Hedgehog projectiles that missed their target would sink to the ocean floor and remain inert, creating no explosions and no sonar interference. This meant that silence after a Hedgehog attack indicated a miss, allowing the ship to maintain sonar contact and fire again immediately. But explosions meant hits, confirmed kills, not the ambiguous damage assessments that plagued depth charge warfare. A ship that fired Hedgehog and heard 24 detonations in rapid succession could be certain that at least some projectiles had struck the submarine's hull, almost certainly causing fatal damage. HMS Westcott, a V and W class destroyer modified to carry Hedgehog, conducted the first successful combat attack on January 11, 1942, against an unidentified U-boat in the western approaches. The submarine was not sunk in this encounter, but the weapon system had proven operationally viable. Throughout 1942, Hedgehog installations increased gradually across convoy escort groups as production capacity expanded and training programs familiarized crews with the new weapon. By early 1943, approximately 150 Allied escort vessels had been equipped with Hedgehog systems. The weapon's effectiveness was becoming statistically undeniable. Ships equipped with Hedgehog achieved kill rates of approximately 24% per attack, nearly 5 times the success rate of conventional depth charge attacks. But these statistics were not yet widely known among U-boat crews, who remained largely unaware that Allied anti-submarine capabilities had fundamentally changed. U-175, a Type IXC submarine commanded by Kapitänleutnant Heinrich Bruns, departed Lorient on February 20, 1943, for patrol in the North Atlantic convoy routes. Bruns, age 32, had commanded the boat since August 1942, completing one previous patrol, during which he had sunk 2 merchant ships, totaling 14,000 tons. His crew of 57 men included 20 veterans with previous combat experience and 37 sailors on their first operational patrol. The transit across the Bay of Biscay proved uneventful. By March 5, U-175 had reached her assigned patrol area, approximately 400 miles west of Ireland, operating as part of Gruppe Raubgraf, a wolf pack of 18 boats deployed to intercept eastbound convoy HX228. Ultra-intelligence had decoded German naval transmissions, revealing the wolf pack's position, and convoy HX228 had been routed significantly north of the patrol line, but German headquarters was unaware of this compromise. On March 9, U-175 detected a small convoy of 7 merchant ships with 3 escorts, stragglers from convoy ON-169 that had become separated in heavy weather. Bruns maneuvered into attack position, targeting a 6,000-ton freighter. 2 torpedoes were fired from bow tubes 1 and 3 at 1900 hours. Both missed, passing ahead of the target due to incorrect speed estimation. The escort vessel HMS Swale, a River-class frigate commissioned in November 1942, immediately detected U-175's position through high-frequency direction, finding equipment that had triangulated the torpedo firing signatures. Commander Peter Gretton, Swale's captain, ordered maximum speed toward the contact, ASDIC operators acquiring solid sonar return at 1,200 yards range. Bruns ordered crash dive to 180 feet, standard evasion depth, that placed the boat below the layer thermocline, where temperature differences would theoretically degrade sonar performance. The boat leveled at depth, electric motors running at slow speed to minimize noise signature, crew maintaining absolute silence. Hydrophone operators reported the approaching escort, propeller sounds growing louder, indicating the surface ship was closing rapidly. Standard procedure dictated that Bruns should order course change and speed increase as the escort passed overhead, exploiting the sonar blind zone to evade. But Commander Gretton aboard Swale had no intention of allowing standard procedure to play out. At 600 yards range, he ordered Hedgehog prepared for firing. The weapon was loaded and trained forward, safety interlocks released. At 250 yards range, ASDIC operators confirmed target depth at 170 feet and holding steady course. Gretton ordered fire. The Hedgehog salvo launched with distinctive popping sounds as cordite charges propelled projectiles off their spigots. 24 bombs arced forward through the darkness, splashing into the Atlantic in rapid succession approximately 230 yards ahead of Swale's bow. Inside U-175, hydrophone operator Matrosengefriter Karl Eisner detected the splashes through his headphones. Multiple small impacts, unusual but not immediately threatening. Depth charges made distinctive, heavier splashes, followed by the terrifying sound of their descent. These were different, lighter, more numerous. Eisner reported to the control room, uncertain what he was hearing. Bruns, standing beside the depth gauge and compass, processed this information with growing concern. Multiple splashes meant multiple charges, possibly a coordinated attack by several ships. But sonar had only detected one escort. Perhaps aircraft were involved, dropping bombs while the ship positioned for depth charge run. He ordered steady course, waiting to see what would develop. The Hedgehog projectiles sank through the dark water at 23 feet per second, maintaining their elliptical pattern. After approximately 7 seconds, the first projectiles reached U-175's depth of 170 feet. The submarine was positioned slightly off-center in the impact pattern, not perfectly aligned but within the coverage area. 3 projectiles struck U-175 within a 2-second window. The first impacted the forward torpedo room starboard side, penetrating the pressure hull and detonating inside the compartment. 35 pounds of torpex exploded among stored torpedoes and high-pressure air flasks. The secondary explosions were catastrophic, the entire forward section disintegrating in a fireball that instantly killed all 7 men stationed there. The second projectile struck amidships near the conning tower base, the explosion rupturing fuel tanks and battery compartments. Seawater flooding into battery cells generated chlorine gas, the deadly yellow-green vapor spreading through ventilation systems. The third projectile hit aft near the engine room, the blast destroying the electric motor control systems and fracturing the pressure hull in multiple locations. U-175 began sinking immediately, the massive flooding overwhelming all damage control efforts. The submarine tilted sharply, bow down as water filled the forward compartments. Emergency lighting failed as electrical systems shorted. Men trapped in the stern compartments attempted to seal watertight doors, but the pressure differentials from rapid flooding made it impossible to move the heavy steel hatches. The boat passed through 300 feet depth, well beyond her design limit of 750 feet, with hull compression audible throughout the boat as steel plates buckled under increasing pressure. At approximately 500 feet, the pressure hull catastrophically failed, imploding with such violence that the shockwave was detected by Swale's ASDIC operators as a distinctive crushing sound. All 57 crew members died within 90 seconds of the first projectile impact. The debris field rising to the surface included wooden furniture, clothing, papers, and a spreading oil slick that marked U-175's grave. Commander Gretton observed the evidence through binoculars, noting the time: 19:14 hours, March 9, 1943. HMS Swale's first confirmed U-boat kill using Hedgehog had taken less than 15 minutes from initial contact to final destruction. The engagement demonstrated Hedgehog's tactical revolution with brutal clarity. No depth charge pattern had been dropped, no sonar blind period had occurred, the submarine had been given no opportunity to evade during weapon delivery. The attack had been conducted with such precision that only 3 projectiles of 24 fired had struck the target, yet those 3 hits had been absolutely fatal. Word of these new tactics spread slowly through the U-boat force during spring 1943. Combat reports from boats that survived Hedgehog attacks described confusing encounters where surface ships fired weapons that produced multiple splashes but no explosions unless they hit. Hydrophone operators reported sounds unlike conventional depth charges, lacking the familiar whoosh and predictable detonation timing. Kapitänleutnant Klaus Bargston, commanding U-521, filed a detailed report after an engagement on March 25, 1943. His boat had been attacked by a British corvette that fired an unknown weapon producing approximately 20 splashes in rapid succession. No explosions followed. The corvette maintained sonar contact throughout, something that should have been impossible if depth charges had been used. Bargston escaped by going deep and running silent for 6 hours, but the encounter left him deeply unsettled. "The British have developed a new weapon," Bargston wrote in his war diary. "It does not explode like depth charges." The escort maintained continuous contact throughout the attack. "We heard projectiles striking the ocean floor around us, metal impacting rock, but no detonations. If any of those projectiles had struck our hull instead of the seabed, we would have been destroyed. This is unlike anything we have trained to counter." Admiral Karl Dönitz, promoted to Commander-in-Chief of the entire Kriegsmarine on January 30, 1943, while retaining operational control of U-boat forces, received these reports with growing concern. His headquarters staff at BDU, Befehlshaber der Unterseeboot, maintained comprehensive files on Allied anti-submarine weapons and tactics. By April 1943, enough encounter reports had accumulated to recognize a pattern. A technical working group was convened at Kiel Naval Arsenal to analyze the evidence. Intelligence officers interviewed survivors from several boats that had been damaged but not destroyed by the mystery weapon. Hydrophone recordings were examined. Physical evidence was scarce, as most boats encountering the weapon had been sunk, but one damaged boat had recovered fragments of a projectile that had penetrated the outer hull without detonating, likely a dud round or one that struck at an oblique angle, insufficient to trigger the contact fuse. The fragments were examined by Kriegsmarine weapons specialists. The design was clearly a mortar projectile, finned for stability, with a contact fuse mechanism in the nose. The explosive appeared to be a high-grade military compound, possibly TNT or a mixture. Weight was estimated at approximately 60 to 70 pounds based on recovered fin assemblies. The specialists concluded this was a forward-firing mortar system, probably mounted on the escort vessel's bow or foredeck. The tactical implications were analyzed by Korvettenkapitän Günther Hessler, Dönitz's son-in-law, who served as first staff officer at BDU. Hessler's report, dated April 28, 1943, laid out the problem with characteristic German thoroughness. If the enemy possessed forward-firing mortars that could deliver contact-fused explosives while maintaining sonar contact, then traditional evasion tactics were compromised. The submarine could no longer exploit the blind period when escorts lost sonar contact overhead. Emergency maneuvers initiated at that moment would be detected in real time, allowing the attacker to adjust fire. The contact-fused design meant that only direct hits produced explosions, eliminating the sonar blinding effects of conventional depth charges that had previously aided escape. Hessler recommended immediate tactical modifications. U-boats should dive deeper immediately upon detecting sonar contact, going to maximum operating depth of 750 feet for Type IXC boats or 820 feet for Type IXC boats. This would increase the time projectiles took to reach the submarine, providing more distance for evasion. Boats should maintain higher speeds during evasion, accepting the battery drain in exchange for moving further from the projected impact point. Most critically, boats should attempt to close distance with the attacker rather than flee. If forward-firing mortars had a minimum range, getting beneath the escort might create a safe zone where weapons couldn't be brought to bear. This recommendation represented a reversal of doctrine, as closing on an attacker directly contradicted every survival instinct and training protocol established since 1939. These tactical modifications were distributed to the fleet via encrypted radio transmission on May 5, 1943. But implementing new tactics under combat conditions proved far more difficult than drafting theoretical responses. U-boat commanders, trained for years in established evasion procedures, found it psychologically difficult to override ingrained responses and deliberately close on attacking ships. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. U-630, a Type IXC submarine commanded by Oberleutnant C. Werner Winkler, encountered this tactical dilemma on May 19, 1943. Operating south of Iceland as part of Group Donau, the boat was attempting to intercept convoy HX-239 when HMS Lagan, a River-class frigate, detected the submarine at 1,400 yards range using Type 144 ASD sonar. Winkler, age 26, had received the new tactical directives only 4 days earlier, when his hydrophone operator reported sonar contact and propeller sounds indicating an approaching escort. Winkler faced the critical decision: follow established procedure, diving deep and maneuvering away, or attempt the new doctrine of closing on the attacker to get inside the weapon's minimum range. The decision paralyzed him for 15 seconds, an eternity in submarine combat. His executive officer, Oberleutnant C. Horst Rentel, urged immediate deep dive to maximum operating depth. The chief engineer reported battery charge at 67%, sufficient for sustained high-speed maneuvering. But the new directives had been explicit: closing on the attacker might create a tactical advantage. Winkler ordered the boat to maintain course and depth, planning to turn toward the escort at the last moment and pass underneath at close range. It was a calculated gamble based on incomplete intelligence about a weapon system he had never personally encountered. The gamble failed catastrophically. HMS Lagan's commander, Lieutenant Commander Arthur Eyre, maintained perfect sonar contact throughout his approach. At 300 yards range, he ordered Hedgehog prepared. At 240 yards, with target bearing steady and depth confirmed at 190 feet, he ordered fire. 24 projectiles launched in rapid sequence, creating the characteristic elliptical impact pattern centered on U-630's position. Winkler, realizing the attack was imminent, finally ordered the turn toward the escort and emergency deep dive. But the maneuver came too late. The boat was still completing its turn when the first Hedgehog projectiles reached attack depth. 5 projectiles struck U-630 within 3 seconds. The first hit penetrated the control room, the explosion killing Winkler, Rentel, and 8 other men instantly. The second and third projectiles struck the aft torpedo room and engine compartment simultaneously. The fourth breached the pressure hull near the galley, flooding the crew quarters. The fifth struck the conning tower base, the explosion severing hydraulic lines and electrical cables throughout the boat. With the control room destroyed and the captain dead, no coordinated damage control response was possible. The boat began taking on water from multiple hull breaches. Emergency systems failed. Within 90 seconds, U-630 was sinking rapidly, bow down at 45 degrees, flooding uncontrollably. She imploded at approximately 600 feet depth, with all 44 crew members killed. The entire engagement, from initial sonar contact to final destruction, had lasted less than 8 minutes. HMS Lagan's crew observed the oil slick and debris field rising to mark another confirmed kill. For Lieutenant Commander Eyre, it was his second successful Hedgehog attack in 3 weeks. The weapon's effectiveness had transformed his frigate from a convoy escort, occasionally achieving damaged submarines, into a precision U-boat killer with a 25% success rate per engagement. The statistical evidence of Hedgehog's impact became undeniable through the spring and summer of 1943. Western Approaches Command compiled detailed analysis of all anti-submarine engagements, comparing depth charge attacks with Hedgehog attacks. The numbers told a story that would have profound implications for the Battle of the Atlantic. From January through June 1943, Allied escorts equipped with conventional depth charges conducted approximately 870 attacks on confirmed submarine contacts. Of these, 41 resulted in confirmed kills, a success rate of 4.7%. Ships equipped with Hedgehog conducted approximately 190 attacks during the same period, achieving 46 confirmed kills, a success rate of 24.2%. The disparity was even more stark when examining attacks per kill ratio. Conventional depth charge attacks required an average of 21 separate engagements to achieve one confirmed U-boat destruction. Hedgehog attacks required an average of 4.1 engagements per kill. This meant that a convoy escort equipped with Hedgehog was approximately 5 times more lethal against submarines than an identical ship using only depth charges. Admiral Sir Max Houghton, Commander-in-Chief Western Approaches, recognized these statistics represented a war-winning advantage. If Hedgehog could be deployed across the entire escort fleet, production was accelerated at British and American factories. By July 1943, over 250 Allied escorts had been equipped with Hedgehog systems, with production rates reaching 30 installations per month. Training programs at HMS Western Isles in Scotland and the Anti-Submarine Warfare School in Miami, Florida, incorporated Hedgehog tactics into standard curriculum. New escort commanders learned to approach contacts differently, maintaining steady course and speed to preserve sonar tracking rather than the high-speed maneuvering previously used with depth charges. The weapon's impact extended beyond direct kills. Submarines that survived Hedgehog attacks often sustained damage severe enough to force return to port, removing them from operations for weeks or months. Psychological effects on U-boat crews were documented in interrogation reports from prisoners captured after boats were forced to surface due to Hedgehog damage. Oberleutnant Zur C. Heinz Walkerling, executive officer of U-91, was captured after his boat was crippled by Hedgehog attack on February 25, 1944, and forced to surface. During interrogation at the Combined Services Detailed Interrogation Centre in London, Walkerling described the weapon's psychological impact with remarkable candour. Depth charges? You could evade if you were skilled and lucky, Walkerling stated in his interrogation transcript dated March 7, 1944. You heard them falling, counted seconds, braced for impact. Most times they missed by wide margins. We survived through maneuver and the enemy's blind period after dropping charges. But these new weapons, the projectiles that explode only on contact, they changed everything. The escort maintains sonar contact throughout the attack. You cannot evade what you cannot hide from. The projectiles themselves make no sound as they sink, unlike depth charges. You hear the splashes above, then silence. Either they miss completely and you hear nothing more, or they hit and you die. There is no middle ground, no near misses that allow survival, no turbulence to hide in, just waiting in absolute silence, knowing that contact-fused bombs are sinking toward your position and the enemy above can track every move you make. After our first encounter with these weapons, our crew was terrified of every engagement. Men who had survived 20 depth charge attacks became paralyzed with fear at the sound of sonar pinging. They understood that evasion tactics learned through years of experience were worthless against weapons designed specifically to eliminate those tactics. We were being hunted by a system against which we had no effective defense. This testimony, corroborated by dozens of other captured U-boat crew members during 1943 and 1944, revealed the profound psychological advantage Hedgehog provided beyond its statistical lethality. The weapon's design created a binary outcome, complete miss or fatal hit, that eliminated the graduated survival probabilities U-boat crews had learned to navigate with depth charges. Kapitänleutnant Peter Ottmar von Stockhausen, commanding U-231, encountered Hedgehog for the first time on May 11, 1943, during the catastrophic convoy battles that would become known as Black May. His boat was operating with Group Donau against convoy SC-129 when HMS Jed, a river-class frigate, detected U-231 at 1,800 yards range. Von Stockhausen, a veteran commander with 14 months of combat experience, ordered standard evasion, diving to 220 feet and increasing speed to 7 knots while executing a 90-degree turn to port. But Commander Robert Sherwood aboard Jed maintained perfect sonar contact throughout these maneuvers. The ASDIC beam tracking the submarine with precision that would have been impossible had depth charges disrupted the water. At 260 yards range, Sherwood ordered Hedgehog fire. The salvo launched cleanly, 24 projectiles arcing forward into the evening darkness. Von Stockhausen's hydrophone operator detected the splashes and reported multiple small impacts. Nature unknown. Von Stockhausen ordered emergency deep dive to maximum operating depth, 750 feet, for the Type IXC boat. The Hedgehog projectiles, already sinking toward the submarine's previous depth of 220 feet, began missing above as U-231 descended rapidly. 23 projectiles passed through empty water and struck the ocean floor without detonating, their contact fuses designed to distinguish between mud and steel. One projectile, its trajectory slightly steeper due to manufacturing variations, struck U-231's conning tower as the boat descended through 300 feet. The explosion was relatively small compared to depth-charge detonations, only 35 pounds of torpex, but it occurred directly against the pressure hull, rather than at standoff distance. The blast penetrated the conning tower's lower structure, rupturing the main induction valve and fracturing the high-pressure air manifold. Seawater flooded into the control room through the damaged induction system. Von Stockhausen ordered emergency surface, the only option with flooding compromising the boat's ability to maintain depth control. U-231 broached bow first in heavy seas at 21:47 hours, her decks awash and conning tower damaged, but the pressure hull still intact. HMS Jed immediately illuminated the surfaced submarine with searchlights and opened fire with her 4-inch main gun. The engagement was brief and one-sided. U-231's deck gun crew attempted to return fire, but were swept away by shellfire before they could train their 88mm gun on target. Von Stockhausen, recognizing the hopelessness of surface combat against a fully armed frigate, ordered abandon ship and scuttling charges set. The crew evacuated into freezing Atlantic water as demolition charges detonated in the engine room and torpedo rooms. U-231 sank stern first at 22:13 hours on May 11, 1943. HMS Jed recovered 28 survivors from the water, including von Stockhausen. 14 crew members were killed in the action or died from hypothermia before rescue. During interrogation, von Stockhausen provided detailed description of the Hedgehog attack that British intelligence officers found particularly valuable. The weapon fired while the frigate still had sonar contact, von Stockhausen stated. I heard no loss of tracking during the attack run. The projectile that hit us detonated on contact with the hull, not at preset depth like conventional charges. Had we maintained our depth instead of attempting emergency deep dive, multiple projectiles would have struck us, and we would all be dead. What shocked me most was the realization that our evasion training was obsolete. Every tactic we learned at submarine school assumed the attacker would lose sonar contact during the final approach. We were taught to exploit that blind period. But if the enemy maintains continuous contact and fires weapons that detonate only on direct hit, there is no effective counter. You can only hope their aim is imperfect, or that you are lucky enough to be between projectiles in the impact pattern. This assessment, coming from an experienced U-boat commander who had survived numerous depth-charge attacks during previous patrols, confirmed British tactical intelligence about the weapon's psychological impact. U-boat crews were not merely being sunk at higher rates, they were being confronted with a weapon system that invalidated their entire tactical doctrine. May 1943 would prove the turning point month in the Battle of the Atlantic, though Hedgehog was only one factor among many contributing to the catastrophic U-boat losses. Improved radar, increased escort numbers, better tactical coordination, long-range patrol aircraft coverage, and ultra-intelligence all played crucial roles. But Hedgehog's contribution to the 41 U-boats lost during May was disproportionate to the number of ships equipped with the weapon. Of the 41 boats lost in May 1943, at least 9 were confirmed destroyed by Hedgehog attacks, with an additional 5 probably sunk by Hedgehog based on engagement reports lacking definitive confirmation. This meant Hedgehog accounted for approximately 22% of all U-boat losses during the month, despite being installed on less than 15% of Allied escorts operating in the Atlantic. The psychological impact of these losses rippled through the U-boat force with devastating effect. May losses included several veteran commanders who had survived since 1939 and early 1940. Their deaths removed irreplaceable combat experience and tactical knowledge that German training schools could not replicate. Korvettenkapitän Peter Erich Kremer, one of only a handful of senior U-boat commanders who survived the war, described the May 1943 losses in his post-war memoir, U-Boat Commander, published by the Naval Institute Press in 1984. Kremer had commanded U-333 through multiple successful patrols and possessed intimate knowledge of U-boat operations. May 1943 destroyed the U-boat force psychologically before it destroyed us physically, Kremer wrote. We lost 41 boats in 1 month, approximately 1/4 of our operational strength. But more devastating was the nature of these losses. Boats were being sunk on their first patrols before crews learned combat survival. Veteran commanders with years of experience were dying in attacks they could not evade. The weapons the enemy deployed seemed designed specifically to counter every tactic we had developed. I spoke with several commanders who had survived encounters with the new forward-firing mortars. They described a weapon that fired while the escort maintained sonar contact, eliminating the blind period we depended on for survival. Projectiles that detonated only on direct contact, meaning silence indicated a miss and allowed immediate re-attack, while explosions meant certain hits. The psychological effect was profound. We were being hunted by technology we could not counter. Admiral Dönitz, confronted with unsustainable losses and declining morale, made the extraordinary decision on May 24, 1943, to temporarily withdraw U-boats from the North Atlantic convoy routes. This tactical withdrawal represented an admission that German submarine forces could no longer effectively contest Allied control of the Atlantic shipping lanes, a stunning reversal from the near-victory conditions that had existed just 10 weeks earlier in March. The withdrawal order explicitly referenced the technological advantages Allied forces had deployed. Due to superiority of enemy location, equipment, and overwhelming air coverage, the message stated, North Atlantic operations are temporarily suspended, effective immediately. While this language primarily addressed radar and aircraft, U-boat commanders understood it encompassed the entire spectrum of Allied anti-submarine capabilities, including the devastating forward-firing mortars. Through the remainder of 1943 and into 1944, Hedgehog continued accumulating confirmed kills at rates that far exceeded conventional depth charges. Detailed engagement analysis by Western Approaches, Command Operations Research Section, led by Professor Patrick Blackett, documented the weapon's effectiveness with scientific precision. From July 1943 through December 1943, Hedgehog-equipped escorts conducted 412 attacks on submarine contacts, achieving 93 confirmed kills, a success rate of 22.6%. Conventional depth charge attacks during the same period showed 47 kills from 900 to 38 attacks, a success rate of 5.0%. The statistical advantage remained consistent across different operational theaters and tactical conditions. U-boat losses to Hedgehog attacks included both new boats on their first patrols and veteran submarines that had survived multiple previous encounters with depth charges. U-329, a Type IXC boat commanded by Oberleutnant zur See Hans Otto Schlottfeldt, was sunk by HMS Kite using Hedgehog on February 27, 1944. The boat had completed only one previous patrol and had been at sea for just 16 days when destroyed. U-262, commanded by the highly experienced Korvettenkapitän Heinz Franke, was sunk by HMS Starling, HMS Woodpecker, and HMS Wild Goose using combined Hedgehog and depth charge attacks on January 8, 1944. Franke had commanded the boat since November 1942 and had survived numerous convoy battles. His experience provided no protection against Hedgehog's contact-fused projectiles fired, while escorts maintained continuous sonar tracking. Captain Frederick John Walker, commanding the second support group from HMS Starling, had developed highly sophisticated tactics combining multiple ships in coordinated attacks. Walker's group would become the most successful Allied anti-submarine force of the war, credited with destroying 25 U-boats between 1943 and 1944. Walker's tactics integrated Hedgehog as a primary weapon, using his extensive combat experience to maximize the system's advantages. Walker's famous creeping attack employed one ship maintaining sonar contact while directing a second ship to attack from a different bearing. When Hedgehog was available, the directing ship would guide the attacking ship to optimal firing position 250 yards from the target, ensuring the projectile pattern would bracket the submarine. This coordination eliminated even the small probability of evasion that remained when single ships attacked alone. On January 13, 1944, Walker's group detected U-592 operating southwest of Ireland. The boat was commanded by Oberleutnant C. Karl Baum, age 25, on his first combat patrol as commander. The second support group prosecuted the contact using coordinated tactics. HMS Starling maintained sonar contact, while HMS Woodpecker maneuvered to attack position. At Walker's direction, Woodpecker fired a Hedgehog salvo from 260 yards range at 16:41 hours. 4 projectiles struck U-592, detonating in rapid succession along the pressure hull from bow to stern. The submarine imploded almost instantly, the catastrophic structural failure occurring so rapidly that the crew had no time to react or attempt emergency measures. All 49 men aboard were killed. The engagement had lasted 11 minutes from initial detection to confirmed kill. For Walker's crew, it represented operational efficiency refined through months of experience and training. For the German submariners who died aboard U-592, it represented the brutal reality that individual skill and courage provided no defense against integrated weapons systems designed specifically to eliminate tactical options. German naval intelligence continued attempting to develop countermeasures, or tactical responses to Hedgehog, throughout 1944, but the weapon's fundamental design made effective counters nearly impossible within the constraints of existing submarine technology. The Kriegsmarine's Technical Division analyzed captured equipment and interrogation reports from survivors who had encountered the weapon. The analysis, completed in August 1944, confirmed what U-boat commanders had already concluded through bitter experience. Hedgehog eliminated the temporal and spatial advantages that submarines had exploited against depth charges. No blind period existed during weapon delivery. No sonar interference occurred from misses, allowing immediate reattack. Contact fuses required direct hits, but the 24 projectile pattern provided high probability of hitting a submarine within the impact ellipse. The only potential countermeasures identified were tactical rather than technical. Submarines could attempt to close distance with attackers, getting inside the weapon's minimum range, though this required detecting the attack early and moving toward rather than away from danger, contradicting survival instincts. Submarines could dive very deep, increasing the time projectiles took to reach attack depth and providing more distance for evasion, though this reduced tactical mobility and increased vulnerability if forced to surface in hostile waters. Submarines could attempt high-speed evasion immediately upon detecting sonar contact, though this drained batteries rapidly and was detectable by improved Allied sonar systems. None of these countermeasures provided reliable protection. They merely reduced probability of being hit from approximately 25% per attack to perhaps 15 or 18%, still catastrophically high compared to the 5% lethality of depth charge attacks. The psychological documentation of these tactical dilemmas appeared in war diaries and patrol reports that Allied intelligence recovered from captured boats or from German archives after the war. Kapitänleutnant Heinrich Bleichrod, one of Germany's most successful U-boat aces with 25 ships sunk totaling over 160,000 tons, described the evolution of anti-submarine warfare in a patrol report from November 1944. The enemy has systematically eliminated every advantage submarines once possessed, Bleichrod wrote. Their radar detects us on the surface regardless of darkness or weather. Their aircraft patrol continuously with ranges exceeding 1,000 kilometers from base. Their escorts maintain sonar contact throughout attacks, using forward-firing weapons that require direct hits rather than proximity. Their intelligence seems to predict our positions before we arrive. Every patrol becomes a survival exercise rather than a combat mission. Bleikrot survived the war, one of approximately 10,000 U-boat crew members who lived through the conflict out of the 40,000 who served. His survival was largely attributable to being reassigned to shore duties in late 1944 after his boat was severely damaged. Had he remained at sea commanding operational boats, statistical probability suggests he would have joined the 30,000 submariners who died. The final year of the war saw Hedgehog deployment expand across the entire Allied escort fleet. By January 1945, over 600 ships had been equipped with the weapon, including American destroyer escorts, British frigates and corvettes, and Canadian naval vessels. Production had reached over 60 installations per month at combined British and American factories. Training programs had standardized tactics across all Allied navies operating in the Atlantic. The weapon's effectiveness remained consistently high through the war's final months. From January through May 1945, Hedgehog attacks achieved confirmed kills on 47 U-boats, representing approximately 38% of all U-boat losses during this period. The success rate per attack remained above 20%, nearly unchanged from the system's performance in 1943 despite German attempts to develop countermeasures and adapted tactics. U-858, a Type IXC submarine commanded by Kapitänleutnant Thilo Bode, became one of Hedgehog's final victims on April 5, 1945. The boat was operating off the Hebrides when detected by HMS Loch Killin, a Loch-class frigate equipped with both Hedgehog and advanced Type 147 sonar. The engagement followed the now standard pattern refined through 3 years of operational experience. Detection at 2,000 yards range, approach maintaining continuous sonar contact. Hedgehog firing at 240 yards range while tracking remained solid. Multiple projectile hits along the submarine's pressure hull. Catastrophic flooding and immediate sinking with all hands lost. The entire engagement duration: 14 minutes. For the crew of Loch Killin, it was routine anti-submarine warfare executed with professional precision. For the 53 men aboard U-858, it was death from weapons they could neither see nor effectively evade. Germany's surrender on May 8, 1945, ended U-boat operations before the final tactical evolution could play out, but the trajectory was clear. Hedgehog had fundamentally shifted the tactical balance in anti-submarine warfare from gradualist attrition to binary outcomes. Submarines either avoided detection entirely or were destroyed with high probability once located. The middle ground of damaged but surviving boats, which had characterized depth-charge warfare, largely disappeared against Hedgehog attacks. The statistical accounting of Hedgehog's war record documented the weapon's extraordinary impact. From initial deployment in early 1942 through war's end in May 1945, Hedgehog attacks accounted for between 120 and 130 confirmed U-boat kills. Exact numbers vary depending on classification methodology for shared kills, where both Hedgehog and depth charges were employed in the same engagement, but conservative estimates credit Hedgehog with at least 120 confirmed destructions. This represented approximately 15% of all U-boat combat losses during the war, achieved by a weapon that equipped less than 10% of Allied escort vessels for most of the conflict. The disproportionate effectiveness ratio demonstrated that Hedgehog's tactical advantages, eliminating sonar blind periods and employing contact fuses, provided combat multipliers that far exceeded its numerical deployment. The human cost of this technological revolution was documented with precision by both sides. German naval records, maintained with characteristic thoroughness through the war's final weeks, recorded the names, ranks, and service histories of the 30,000 U-boat crew members who died. Allied records documented the circumstances of their deaths. Engagement reports filed by ships that sank submarines, coordinates where boats went down, numbers of survivors recovered. The intersection of these records created comprehensive accounting of individual tragedies that collectively represented strategic transformation. Each name in the casualty lists represented a young man, average age 23, who had volunteered for submarine service, believing he would be part of an elite force that could determine the war's outcome. Each death represented the fulfillment of statistical probability that 3 out of 4 U-boat crew members would not survive the war. For the crews who encountered Hedgehog and survived to describe the experience, the psychological impact proved as devastating as the physical casualties. Interrogation reports from hundreds of captured submariners documented profound demoralization caused by fighting against weapons that invalidated their training and experience. These were not defeated soldiers offering excuses for failure. They were technical specialists who understood exactly what had rendered them obsolete. Oberleutnant C. Wolfgang Luth, one of Germany's most decorated U-boat commanders, with 46 ships sunk and the Knight's Cross with oak leaves, swords and diamonds, delivered a lecture at the Flensburg Naval Academy in December 1943, addressing the psychological challenges facing U-boat crews. The lecture was recorded, and transcripts survived the war. "We face an enemy who has systematically neutralized every tactical advantage submarines possessed," Luth stated. "Their radar operates at frequencies our detection equipment cannot sense. Their aircraft patrol with persistence we cannot evade through submerged endurance. Their escorts employ weapons specifically designed to eliminate the temporal advantages we exploited with depth charges. Most critically, their industrial capacity produces these advanced systems in quantities we cannot approach. The psychological effect on crews is profound and concerning. Men who previously demonstrated exceptional courage under depth charge attack now exhibit paralysis when engaging escorts equipped with the new weapons. They understand, correctly, that traditional evasion provides minimal protection. The mathematics are unforgiving. If enemy accuracy is 25% per attack, and you face 4 attacks per patrol, probability of survival drops below 50%. Over multiple patrols, survival becomes statistically improbable. Luth himself survived the war only to be accidentally shot and killed by a German sentry on May 13, 1945, 5 days after Germany's surrender, in a tragic case of mistaken identity. His death denied historians the detailed post-war memoir he might have written, but his wartime lectures and patrol reports provided valuable documentation of the psychological transformation forced upon U-boat forces by Allied technological superiority. The broader strategic implications of Hedgehog's deployment extended beyond the immediate tactical advantages in individual engagements. The weapon's high kill rate per attack meant that convoy escorts could defend their charges with greater confidence, knowing that U-boat contacts would likely result in submarine destruction rather than damaged boats that escaped to attack again. This confidence translated into more aggressive escort tactics and better convoy protection. Additionally, Hedgehog's contact fuse design eliminated the enormous depth charge expenditure that had characterized earlier anti-submarine warfare. A typical convoy escort in 1942 carried approximately 100 depth charges, each weighing 300 to 600 pounds. After 4 or 5 attacks, the ship would be depleted and forced to return to port for resupply. Hedgehog allowed multiple attacks using the same 24 projectile loadout, which could be reloaded in approximately 10 minutes. This ammunition efficiency meant escorts could remain on station longer and prosecute more contacts before requiring resupply. The operational tempo of anti-submarine warfare increased proportionally. More attacks meant more kills, even if individual attack success rates had remained constant. But success rates didn't remain constant. They increased dramatically because Hedgehog's tactical advantages yielded more hits per attack than depth charges ever achieved. The industrial dimensions of this story deserve emphasis because they explain why Germany could not develop effective countermeasures despite understanding the threat. British and American factories produced thousands of Hedgehog installations between 1942 and 1945. Each installation required precision manufacturing, specialized steel components, and sophisticated fusing mechanisms. Yet Allied industrial capacity made this seem routine. Germany, facing strategic bombing of industrial centers, raw material shortages, and competing demands from other weapons programs, could not have matched this production even if German engineers had designed equivalent systems. The theoretical knowledge required to create forward-firing anti-submarine mortars was not beyond German capabilities. Multiple German weapons designers proposed similar concepts, But industrial capacity to manufacture such weapons in war-winning quantities simply did not exist. This represents perhaps the deepest psychological shock for German U-boat commanders. Understanding that they were not defeated by superior German seamanship or better Allied tactics, but by industrial and technological advantages so overwhelming that individual skill and courage became statistically irrelevant. The bitter recognition that the war had become an engineering and production contest rather than a test of warrior virtues must have been profoundly demoralizing for men trained in naval combat traditions. The post-war assessment of Hedgehog's contribution to Allied victory in the Battle of the Atlantic generated extensive analysis by military historians and operations researchers. The British Admiralty's Official History of Anti-Submarine Warfare, published in 1954, devoted an entire chapter to Hedgehog, concluding that the weapon transformed submarine hunting from a probabilistic contest into a deterministic outcome once contact was established. American naval historians reached similar conclusions. Captain Donald McIntyre, a British escort commander who personally sank 5 U-boats during the war, including 3 using Hedgehog, wrote in his 1961 book, The Battle of the Atlantic, that Hedgehog eliminated the guesswork from anti-submarine attacks and gave escorts a weapon whose employment could be calculated with near mathematical precision. German post-war analysis, conducted by former Kriegsmarine officers including Admiral Eberhard Gott, who had served as Dönitz's chief of operations, acknowledged Hedgehog's decisive impact. Gott's 1953 assessment stated, "The forward-firing mortar employed by Allied escorts from 1943 onward represented a technological quantum leap that rendered conventional submarine evasion tactics obsolete. Our inability to develop equivalent weapons or effective countermeasures contributed significantly to the collapse of U-boat operations in the Atlantic. The weapon's influence extended into Cold War naval development. Both American and Soviet submarine forces studied Hedgehog engagements extensively, learning lessons that influenced post-war submarine design. The emphasis on deep-diving capability, high underwater speed, and silent running that characterized Cold War submarines derived partly from recognition that surface-launched weapons effective at moderate depths against slow submarines would dominate future anti-submarine warfare unless submarines could operate below weapon engagement envelopes. The modern anti-submarine rocket systems employed by contemporary navies, including the American RUR-5 ASROC and the Soviet RPK-3 Metal, descend conceptually from Hedgehog's proven effectiveness as a standoff weapon that could be launched while maintaining sonar contact. Though these modern systems employ guided missiles rather than simple ballistic mortars, the tactical principle remains unchanged. Deliver weapons to the target area while maintaining continuous tracking throughout the engagement. The final accounting must return to the human dimension, the individual U-boat crews who faced Hedgehog attacks and either died or survived, to describe the experience. Their testimony, preserved in interrogation reports, war diaries, and post-war memoirs, documented not merely tactical defeat, but profound psychological transformation, forced by confronting technology specifically designed to eliminate every survival advantage submarines had previously exploited. These men were not cowards or incompetents making excuses for failure. They were highly trained specialists, volunteers who had passed rigorous selection and endured months of demanding instruction. They served aboard sophisticated machines, representing the cutting edge of 1930s naval technology. They employed tactics refined through years of combat experience and continuous tactical evolution. Yet they found themselves hunted by weapons against which skill and courage provided minimal protection. The realization that traditional evasion methods were obsolete, that the blind period during depth charge attacks, which had saved thousands of submarines, no longer existed, that contact-fused projectiles would either miss completely or kill, certainly without the graduated survival probabilities of near-miss depth charges. This understanding fundamentally altered how U-boat crews perceived their operational environment. The Atlantic Ocean, which in 1940 and 1941 had seemed vast enough to hide entire submarine fleets, became by 1943 and 1944 a transparent battlefield where every movement was potentially observed and every contact likely to prove fatal. The transformation was technological, but the impact was psychological, replacing confidence with fatalism and aggression with desperate survival focus. Korvettenkapitän Werner Henke, commanding U-515 before his capture and tragic death in June 1944, expressed this psychological shift in interrogation testimony. "We are no longer the hunters. We have become the hunted. The enemy sees us before we see them. Their weapons reach us while they maintain tracking. Our evasion tactics, refined through years of combat, provide only marginal survival improvement against systems designed to eliminate those very tactics. Every patrol is expected to be our last." This testimony, multiplied across hundreds of surviving crew members, documents the psychological dimension of technological surprise. Hedgehog shocked German U-boat commanders not through a single catastrophic revelation like the Rotterdam radar discovery, but through accumulated experience of engagements where established tactics failed consistently and predictably. The weapon was not secret. Captured projectiles and interrogated survivors provided German intelligence with complete technical understanding by mid-1943, but understanding the threat and countering it proved entirely different challenges. No amount of tactical innovation could overcome the fundamental advantage of maintaining sonar contact throughout the attack sequence and employing contact fuses that confirmed hits rather than creating sonar-blinding turbulence. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.